All right, we're getting started in just a moment. I'm going to give it a second so that we can allow people to hop on the stream if they need to. Today I'm going to be taking a look at this RStudio file from a previous iteration of the live stream, and then bringing this into my document, which of course I've been working on over the past little while. I'll tell you one thing, I have added a section here, a methods section on data collection, etc. I'm going to go ahead and close this door here because we're getting a little bit of background noise. And when I come back, maybe we'll start talking about this stuff. All right. So, let us take a look at this methods section that I've just written. This is something I was working on outside of the live stream. I know I'm cheating a little bit here. I said I was going to do this entirely during the live stream, but I thought this would be a little bit more impactful to run through this other stuff and just show you kind of how I'm thinking through the presentation of quantitative results. So the first thing, right, the data collection here. Oh, hey kitty. We've got our cat here, trusty Ellie cat, here to help us with our method section. She loves to be on camera. It's crazy. She'll be hiding like completely in another part of the house, and then instantaneously, whenever I start streaming, she comes up here and wants to be part of the show. Anyway, you can see that in my method section, I kind of have two main pieces here. I've got the data collection section where I talk about the sources of the variables, the IV, the DV, all that stuff. Right. I've also got another section in which I talk about the DV and IV and control variables level and their sort of description of the actual variables themselves. So I've got a couple of paragraphs here on where the stuff came from. And then I've got a couple of paragraphs here about how you actually measure these variables, what their actual scale is and stuff. So continuous numeric variables ranging from 0 to 100. As it turns out, in my little live stream project here, I've got some nicely behaved data. You know, this is a nice data set to work with because we've got stuff that runs from 0 to 100. We've got this Trump share variable, which is also a percentage, right? And GDP per capita, which is a numeric. It's essentially an integer that runs theoretically to infinity. And so I describe those, right? I do mention a couple of things about my variables here. I talk about how this might be what we might call a weak proxy for the DV concept. My DV concept is not super well measured here, partially because it is low in content validity, which was one of the answers on an earlier quiz. Essentially, it's only measuring one really like fragment, like small fragment of a larger concept, which is, of course, concern over the COVID-19 phenomenon. And then we've got the Trump vote shares, the IV. So I describe all these variables in turn before moving to the methodology section. And so the methodology section, I describe here the studies and mixed methods investigation of the effects of partisanship on statewide levels of concern over COVID-19. And so to do this, I employ several techniques. Bivariate analysis. So specifically, I talk about the most appropriate techniques being scatter plots and Pearson correlation tests. So that's really helpful. And then I do OLS regression, also called multiple linear regression, to assess the effects of the IV and the control variable on the outcome. And then finally, you can see I engaged in a comparative hypothesis testing case study of California and West Virginia. So these are two states that I've chosen that might be good for my qualitative analysis. I say these states represent ideal tests of the hypothesis because they differ substantially in Trump vote share as well as interest in COVID-19 PPE. So they're kind of are my diagonal cases where like one is high, one is low. And so I also mention the Q taking element of this study, which I haven't really been able to address super well in my quantitative section because I was too lazy to go and get additional measures of gubernatorial Q giving, for example. So you might notice in my theory section I talk a lot about the role of gubernatorial Qs here, and so I'm able to pick up some of that control variables or some of that like threat to validity stuff in my qualitative results more so than my quantitative results. And so I'm essentially looking at what Jim Justice in West Virginia said and what Gavin Newsom in California have said about COVID-19 and how that might have influenced the way that people responded to the crisis. So that's going to be the next section for me to engage. It's going to be my qualitative analysis section. But for now, I want to go back into my quantitative results and sort of get these things on the page and kind of describe them a little bit. So if we go back into this composition 6.r file that I was working with when I earlier ran through this, I'm going to go ahead and import my data again from Excel. Using that Excel import thing, I'll bring in my data set, which is just called DAT. Remembering that the most important step here is that the file will be called DAT with lowercase dat. Bring that in, make sure that the headers all look right, make sure that these variables all look right. Looks good. We can import it. It's going to pull up this viewer. We can just close that viewer. We don't need to look at it. We've already seen it several times. I'm also going to run this. I'm going to have Tidyverse and Stargazer installed here. So we can see we've got this little table with the packages here that make me happy. And then we've got this thing, which it sounds like, it's all red text. It looks like it's really scary. But in fact, this is no problem. It's just saying, look, please cite Marek Hlavatz anytime you use Stargazer. I mean, that would be a nice thing to do if we're using Stargazer in a published paper. I'm not going to require you to do that for this paper, though. We can look at a couple of our variables as we did in the previous section, just to make sure this works. Concern pre, concern post. Concern diff that I created. I'm gonna comment this out. I don't think that there's a need to create this because it ends up making the interpretation kind of difficult. And part of that is I went back and I read more about Google Trends. You can see that in my methods section, this is important, right, to describe. I said in each case 0 indicates the least interest in the term, while 100 indicates the maximum interest in the term in the given period. And so these two are not super comparable variables when we're comparing across them. Like an increase in one, it doesn't necessarily correspond to an increase in another in each state. So like if say that like California's concern goes up by 20%, that doesn't mean that there's going to be a 20-point increase in post relative to pre. Because what it's doing is it's capturing variation across the states in the pattern. And so it's not really a very useful metric to compare like specifically pre-post. But within each of these variables, we actually get a good understanding, I think a good way of capturing the potential variation in the pattern. So making a difference scale here is probably not the thing that we want to do. Just from having read a little bit more about how to code this. I'm actually going to get rid of this just because it's a little bit confusing, a little bit counterintuitive. We can look at Trump share. It looks like that's probably working quite well. Remember I rescaled these. I said Trump share was going to be that times 100, so it's a percentage and not a decimal. GDP per capita, I was going to take that per every $1,000. So we can perform those recodes. And we made sure using str that these were in fact numeric and not character variables. And so everything was good. We can make sure to throw out any potential NAs that we have. We don't have any. This should be fine. We should have 50 cases, 50 observations of these variables. And so if you recall last time, I had this jittered plot where I created a label and everything, and it looked really pretty. Oh, I haven't installed my text repel function. That was my fault. I should always go up here and make sure that all my packages get in here. Let's see. It's called GG repel, is that right? Yeah, here we go. So now I should be able to do this plot with my text repel. And lo and behold, we've got this beautiful scatter plot where we can see the different states. Again, the scatter plot is a bivariate analysis showing the relationship between these things. I'm going to go ahead and export this. I can say copy to the clipboard. Copy plot. And in fact, I'm going to do one additional thing before I bring this into my Word document. I'm going to give this the name. I'm going to call this figure 1 because I think this is going to be the first table in my paper, and as a result, I want to give it a label, figure 1. So I'll take this, again, I'll make it into a fairly, interpretable sort of rectangular shape. I can move this around a little bit to make it square. I'll go ahead and export. I'm going to copy it to the clipboard. There it is. I'll say copy plot as a bitmap. And then I will go back to my document. And I will throw this in. Just paste this in. Look at how pretty that is. Paste this into my Word document. So there's figure 1. Keep that in there for now. What else do I need? I need some other analyses, do I not? Probably want to do another jitter label plot here. I'm going to call this one figure 2. So I'd already created this, so I can just run that command. We'll get to the correlation coefficients in a moment. Okay, so this one is interest in medical gloves versus state GDP per capita. Oh, I will say I'm going to put in an xlim here command. It's called xlim. And I'm going to make that 0. I guess we'll put this in here. 0 to 100. And again, you don't need to do this necessarily. This is just so that these are comparable on their scales. So what this is saying is like, look, here's 0%. Oh no, this is GDP per capita, so I don't want 0 to 100 here. Although technically that looks kind of nice. But earlier I had done this where the X limits are 0 to 100 because this was the percent of Trump vote share. So this is actually from 0, right? We've got 0, 0 here on the plot. And then here, this is states in which it's over $100,000. I bet if I take this away, we might even see some additional states, though. So we do not necessarily want to actually create, yeah, I guess no, it's still up there, 100,000. Anyway, this scatter plot, right, it's not ending at 0, 0. But because there's all this white space over here where there's no states, right? Mississippi is the poorest state per capita. New York is the wealthiest state per capita. We don't need to necessarily include all that white space there. So in retrospect, I'm actually going to keep this the way that it is. So copy it to the clipboard, copy the plot. We see again that there's this nice kind of positive relationship. You can see again comparing. All right, there's this white space over here because I forced this plot to range all the way from 0 to 100 on the vote for Donald Trump scale. So this one, we can see there's clearly some kind of positive relationship. Here, there's some kind of negative relationship, certainly. But that's something that we're going to want to write about in just a moment. Trying to think, what else do we want here? Other plots? I can imagine at least one more plot that would be useful. And that is, I probably want to look at concerned post. So I will pull this in. I'm going to paste this thing. So this will actually be figure 3. So this is concerned post. Enable state ID. And again, this is going to be figure 3, scatter plot. There's some medical gloves versus Trump vote share. And this is March. March 16th through April 16th, 2020, instead of in the previous period. So I can make this plot with this alternative DV, essentially. And you'll see that essentially it's more or less the same. But that's still a nice check, something I can throw in as a way to look at this relationship. Potentially, the idea would be in the presence of stronger gubernatorial cues. But again, something that I can't test explicitly. So I'll bring that in. I've got my third scatter plot. We're going to write around these plots. I think this is always a really, really good way to do this, is to just write around your plots. So there's going to be writing here, there's writing here, etc. I'm going to get all these things on the page before I write them, though. The bivariate analysis, let's make sure we do some correlation tests so we have those numbers in there to write with. First thing is we want to look at the correlation between concern pre, our original DV, and then the Trump vote share. You see that the correlation is essentially negative 0.37. So this is associated with figure 1. I'll say core right now. It really is, the way we write this is usually with an R, a lowercase r. And let's see, we've got a p-value here. P is less than 0.01. So that's my first correlation coefficient that's associated with that one. I'll just do this on here. We've got, let's see, where's our next one? Yeah, this is concern pre. And GDP per capita, that's right. Run that one. Our correlation test shows that our correlation estimate is 0.11, so it's much smaller. Let's see, let's look at rounding. Yeah, so it's 111, so we can keep that rounding down, doesn't round up. And the p is 0.44, so it's much greater than 0.05. P equals 0.44. Okay, so that's that one for scatterplot 2. And then for scatterplot 3, this other scatterplot where we're looking at Trump vote share in this later time period, I can do this concern post and Trump share run. We can see here that, again, the p-value is actually much smaller and the correlation coefficient is actually much stronger. So in fact, it's gotten stronger, which actually leads me to think that maybe the governors in blue states are starting to cue their audiences more than the governors in red states. So now we can say here the R is equal to negative 0.59. And the p-value here is very small, less than 0.001. It's just a minuscule statistic. So that's really helpful. And then, just for the purposes of getting all this on the paper before I start writing it, I always like to do that. I'm going to go now from my bivariate analysis. I'm going to go into results of OLS regression. Okay, so in the regression, if you recall, I had built up some of these models where I had this model 1, where we've got Trump share as the one and only variable in there. Just very briefly, I've summarized that for you. You can see that Trump share has a significant negative effect, as we expected. And we interpreted that here, we'll be reinterpreting that in a moment. Then this model where we've got GDP per capita, this control variable in there, control pre. And then we looked for some of these cases to interpret. So now we've got two models essentially. So I'll select those models for presentation. And so of course what we want to use is the Stargazer tool. So we can say Stargazer mod 1, mod 2, and then we have this this additional type equals text, I believe that's right, command. So if we run this little command, we'll see that we get the Stargazer table that we're used to seeing now, the dependent variable. Now, here's the thing that I wanted to really show you. This is a kind of a nice thing. So you may have seen this, and certainly it's very possible to take this thing out of the interpreter, or out of the this display, and copy it, and then like paste it right into your paper. And I know many of you have done this, and it works out fine. You can just pull it, you can put it in there, and it looks fairly nice. The thing that I would say is that you can actually run the Stargazer command with a slightly different flavor, which actually makes it even prettier. And this is the thing that I wanted to show you. If you look at this, if you run this command, I guess I'll put it up here so we can see. Here, where are my files going? Okay, you can run the command getwd. Now this is not getwd40, this is not some kind of command to lubricate the insides of your computer or something. Getwd stands for get working directory. And the working directory is where your files are going to get spit out if RStudio were to create any files. So far we've simply been copying plots and taking stuff right out of the interpreter and pasting it into documents. In this case, R is actually going to be creating a new file on our computer and spitting it out. The same way that you might download a file from the internet. If we run that, we'll see getwd. This is where my files are going. And so this is good to see because we can see that it's going to the right folder. It's going to my Livestream project folder in my Dropbox where all my course materials are. So I already set my RStudio to go to that place. You don't necessarily need to do that. You can just run this and find out where it's supposed to be going. So then you can go to that file folder location in your computer. Maybe it's My Documents, maybe it's something else, and you can go and retrieve any file that Stargazer is creating. So what I'll do is I'll just run, right? So I'll say create a Stargazer table that exports into a .html file. So this is the way to get an even prettier table. So I'll just run Stargazer mod 1, mod 2, And in this case, my type is going to be not text, but HTML. Okay. And then I have one additional command here, which is going to be out. That's out, and I will call this full model.html. Now this should, if I'm remembering my Stargazer command correctly, this should work. So I'll run this, and you'll see actually that it spits out like a giant thing of like crazy garbage, right? Like, what is this? Well, what this is actually, what all this is actually HTML. This is actually the raw code that creates a table in any, any HTML, any document that you might be reading on the internet. So, if I were to go to, for example, let's just go to my website because it's, top of mind. If we go to, like, for example, my research page, right? Here's all this stuff that I work on. If we were to inspect this, right? If you press the inspect, let's see, how do we do that? I think we just, yeah, there we go, inspect. If you press inspect on Google Chrome or on any other browser, it'll pull up this craziness over here. That's actually the HTML that builds this website. Okay, so it looks actually, if you go back to RStudio, it looks a lot like that stuff. I don't have a table in here. This is just like bullet points. I don't really have a table in here, but it would look a lot like a table if it would look a lot like this if there were a table in that site. But so now we can think about how we can take this stuff and turn it into something that's legible, something that's a readable table, the way that we might read a table on a professional website. And so the way to do that ultimately is to take this stuff and open it in an interpreter that allows us to copy and paste it into a Word document. So I'm going to go to my Livestream project folder, and you'll see, amazingly, because I specified this command, let's go back and bring this open, out equals fullmodel.html, that out command, that specifies that it should create a file called fullmodel.html, and it should plonk it into my folder, the folder that I specified through my getwd. So you're starting to see really like just how powerful RStudio is, right? It can do a lot of stuff in just like one, like one function, 3 lines of code that allows us to do some really nice visualization of data. So if I were just to click on this, right now my HTML files are associated with Google Chrome. If I open that up, it'll open in Google Chrome. It's a local file that comes out through the Chrome interpreter. And you'll see that this is like a really pretty table, right? This is like the kind of table that you'd see in a published paper. And you can generally take that and you can, copy it and you can try to bring it into your document. It may or may not look fairly good. This is usually going to be okay unless your table's got a lot of bells and whistles and is very complicated. You can just open that up in Chrome or in Firefox or any other browser, and then just copy and paste that stuff because it's still in a tabular format. The other way that you can do it is you can go back to your folder and you can right-click on this thing and you can say, what do I want to open this with? Actually, you can say, I want to open this with Microsoft Word. And so if you, let's see, we have more apps. Where's Word? Here we go. It should be able to, no, we don't want to make it our default web editor, but we can open this thing in Word by itself, and it's in a really nice table form. It's exactly the way that it needs to look, and we can copy that, and we can paste it. I'm actually going to I'm going to use this one because it's even better formatted, right? Everything's in a cell. It's really nicely formatted, whereas this one is maybe a little bit wonkier. I'm going to take this thing out. I'm going to paste in my really nicely formatted one. We can also change the font here. We can make sure that this is Times. We can make sure that it's 12-point fonts. We can make sure that it conforms to all of the stylistic things that we need it to conform to. Okay, so there's that. Now notice that another thing that we could do is see these variable names. Like, these are really hard to interpret sometimes. And so because this is editable in the table, we can go ahead and we can change it. Right? We can say the dependent variable here is searches for medical gloves, and we can put in a scale here, 0 to 100. So we know the range of the variable. Trump share here, we can replace this title with % vote for Trump. in 2016. Notice also, again, this isn't messing up my formatting because this is all in tabular format with different cells. GDP PC, I can make this GDP per capita. This is, I think it's 2019. And we can say 2009 change dollars if we wanted to, because that's, of course, the scale. Oh, actually, I'm sorry, this is in $1,000 increments. So again, we want to be, clear. And we've got our constant, we've got our observations. I'm just going to make sure that this falls onto another page so that it's all in one thing. This is suddenly, oh, there's a couple of things that maybe don't come in here. This is 0.05. Oh, I'm sorry, this is actually 0.1. Sometimes Stargazer's a little bit finicky with that. It makes the first star 0.01 because it's saying that it wants you to be a little less skeptical of these results than some political scientists, for example, would be. And so this is now a really, really pretty table and something that I'll be able to explain a lot better in text. So again, the way to do that is to run this. And again, this is in this Composition 6 file, which is in the folder that you have access to, the Livestream project folder. You can grab this snip of Stargazer code and you can adapt it to your own devices. If you want to do this, create a thing called full model, go use get working directory to find out where it gets plonked by RStudio, go into your folder and find it, again, open it up, and then open it in Word. Right, open with Microsoft Word to be able to copy and paste it into your document. So it's a really, really powerful tool. It makes a really cool, pretty table. So that's just a little shortcut. Again, the text-based table with like the single spacing text, that works fine. It's very easy to tell what it is. But if you want to change your variable labels, for example, that's not going to be so easy, right? Because let's see what happened. Okay. Managed to make this too big. Yeah, there we go. Sometimes this thing fights with you a little bit. But yeah, it's more powerful. Okay, let's get into the actual writing of this stuff. So we've got our bivariate analysis. I'll get this going. So the first bivariate analysis to be performed is a scatter plot showing the relationship between the IV, Trump vote share, and the DV interest in medical gloves from February 16th, 2020 to March 16th, 2020. Okay, so figure 1, this is one thing we always want to be referring to these, like link these together in our writing and in our descriptions. Figure 1 contains the results of this analysis. So often I'll just introduce this, right? This is kind of a basic introduction to the scatter plot, and then I'll come down to beneath it and give you my explanation. One nice thing to think about, one kind of like heuristic to keep in mind, is you want to make sure that if this were to somehow get like, I don't know, obscured, broken, if you printed this out and like the printer smeared it and you couldn't see any of the points, I should be able to read the paragraph below this and still know what the general pattern is. So that's something that I think a lot of novice writers of research projects have a hard time with, is that they don't realize that you want to make sure that it sounds redundant a little bit, but your writing is always sort of paralleling and reinforcing the trends that you can see in the plot. Right? So you don't want to just be like, as you can see, right, there is a pattern. Done. That's not sufficient, right? We want to tell the audience our interpretation of the pattern. So you could say something like, Fig 1 demonstrates a clear negative association between Trump vote share and interest in medical gloves, while states like New Mexico, New York, and New Jersey are fairly high in values of medical glove searches, they also appear to be low in support for Trump. Meanwhile, the bottom right quadrant of Fig 1 shows states like Arkansas, Oklahoma, and North Dakota, which are strongholds of Trump support and relative laggards in their searches for medical gloves. And again, you can even get more specific with this, like certain points you could talk about, right? Like Arkansas, for example, I could go back in the data and figure out exactly. You could say Arkansas is a notable. Maybe I'll take West Virginia here. It'd be kind of interesting. West Virginia is a notable exception to this trend, as we see that it is somewhat higher than average in searches for medical gloves, with a score of, I'm just going to guesstimate, this is like 70, well, 50, 72. I could go back into my RStudio and figure this out. Right, I could say, show me the data, right? You'd actually find this out. So here's West Virginia. Where are they? West Virginia here, they're actually concern pre 71. So it's close. So it's sort of 71 out of 100 in concern. Yet, as we see that it is somewhat higher than average in search for medical gloves, yet it is also a Trump supporting area with a vote share of, let's see here, 68.5. With 68.5 of voters in 2016 supporting. Okay, so that again like helps to sort of build in a little bit more detail, like more granularity. Like I know more about this, and then we can conclude this with my interpretation of this statistic. Right? We could say, statistically speaking, this relationship is also fairly strong and unlikely to have occurred by chance alone. The Pearson correlation coefficient is r equals negative 0.37. P less than negative, P less than 0.01. Word doesn't like me using fairly. These are sort of weasel words, right? I say this is strong, pretty strong. I'd say this is pretty strong as far as correlation coefficients go. But anyway, I mean, this is really all we need here. We just need to report this correlation coefficient. I can go ahead and fill in these other, this is going to look very much the same because these are all the same type of analysis. I'd love to have shown you something like a bar chart, but I want to get into the regression interpretation just for now. And the last thing that I'll do in today's live stream, I'll come back and clean up these other interpretations in a little while so you can see that in the final project draft in the folder. So we might want to give a statement that, while these bivariate trends are strong and they suggest that there's some sort of pattern, we're in need of more robust quantitative analysis. So I could say something like that, right? While these or while figures 1 through 3 suggest that there is a strong association between the IV of Trump support and searches for medical gloves. These bivariate analyses do not permit for the estimation of the relationship in, let's see, an estimation of the relationship that is robust to potential sources of spuriousness. In particular, the regression models contained in Table 1 below, wow, I can't spell that, demonstrate what happens to this estimate when we control for the variable GDP per capita. Okay, so I want to give a title to this. This is another thing that our table doesn't always do for us. We can say here, actually, do I want to put this here? Sometimes you can get rid of this, delete entire row. Just oh well, it doesn't want to. This, again, sometimes you have to fight with these tables that come from other sources. I'm going to merge the cells maybe. There we go. So we can say, because again, we know what the dependent variable is. Of course it's going to be here. I'll say table 1 regression analysis predicting. Okay, so there we go. I can bold it too if I want. So now our table also conveniently still fits on one page. Also, what do I think to center this? It's a little bit wonky on its over there on the. Oh, this is, you have to highlight the whole thing by clicking up here. This is one reason why I don't love Microsoft Word. You have to fight it a lot. But yeah, that might look even better. Okay. So we've got our table, we've got our statement here, but now we want to engage in additional interpretation. Okay, so looking across the columns of table 1, we see the results of 2 regressions. The first regression includes only Trump vote share as its sole predictor. The other regression includes both GDP per capita and Trump vote share. Model 1, all right, so we've got model 1 here, demonstrates that by itself, Trump vote share has a strong and statistically significant effect on, I could say negative effect. Oh, statistically significant negative effect on searches for medical gloves. Specifically, and here comes our statistical interpretation of this relationship, right? Specifically, a 1, what's the unit? A 1 something increase. This is going to be a 1% increase. Increase in Trump vote share in the 2016 election is associated with a, what's our coefficient here? Well, it comes here next to the stars. We don't need to worry about this thing in the parentheses. This is the standard error. We want this main coefficient, a 0.73, we'll call it. We can round. 0.73 point decrease in what? Searches for medical gloves. Gloves on a 0 to 100, not 199, there we go. P What's the p-value here? Well, we see that there's 3 stars, right? It's less than 0.01. So that's a robust, significant relationship. So that's great, right? We can see that there's a strong and clear interpretation of the direction and of the strength of this thing, right? So we could also say, for illustration, consider a state that became that I don't know, maybe welcomed an influx of Trump voters such that its vote share for Trump would have become 5 points higher. So basically what we do is multiply that coefficient by 5. So we'll take 0.728, go back into RStudio because RStudio is a calculator. Yes, Kitty. Kitty's right. 3.64. This 5% increase in Trump support would be expected to raise or to lower, interest in medical gloves by around 3.5 points on a 100-point scale. So that gives us, again, a little bit more of an understanding of the magnitude of this thing, right? It's conceivable, right? Like, imagine, like, across 2 elections, like a state could become 5% more supportive of Trump. We would expect them to then behave, differently by around 3.5 points on this scale. But we want to get into the main regression, right? We can also interpret the results of the full model in column 2. Kitty, you going to help me interpret this this model? Yeah, let's do it. Okay. These results are quite, we'll just say robust, to those presented in model 1. A 1-unit increase in Trump vote share is now associated with let's look at go back to our model, look at our coefficient, 0.83. So a 0.8, we'll round it to 0.84. So this is now almost a full point. Kitty, look up. 0.84 point decrease in searches for medical gloves, all else equal. Okay, because now we're controlling for GDP per capita. We could even just say, because we have one predictor, controlling for a state GDP per capita. And again, this is a p less than 0.01, right? While our theory may have anticipated that GDP per capita would cause spuriousness to be present in the relationship between our IV and DV, it appears that when we hold constant GDP per capita, the relationship between Trump vote share and interest in medical gloves only intensifies. This finding helps to suggest that the pattern observed in bivariate analyses is not merely the product of other features of the states. Additionally, the significance of the predictors and the relatively high R-squared value. We can say R-squared equals, where's that R-squared? 0.148 in the full model helps to reaffirm our basic understanding of the effect of partisanship on concern over viral threats. So this would be, I think, a pretty good interpretation of these regression coefficients. Again, you can see I've thrown in a little R-squared discussion there. There's really nothing else, though, that needs to come out of this table in terms of an interpretation. It's really just, right, these two things. I haven't even talked about this, that it's not significant. I really just said, look, in the presence of this thing that we thought was going to matter a lot, it turns out that this relationship is not diminished in the slightest. In fact, it increases. And so that helps me to make my case. So there's a couple paragraphs on the regression analysis. This whole thing, again, we need to fill in these two pieces. I wouldn't expect much interpretation of this to be any larger than a short paragraph. But really, this quantitative analysis section spans like what, 1, 2, 3, 4, 5 pages, actually, like almost 5 pages, simply because there's some graphs and some tables in there. So I think you could be quite, again, I haven't built my bibliography yet or any of these other sections. That'll be for a later date. But you can be quite confident that you're going to start to build out, like by this point in this paper, Composition 7, like this is a long paper, right? But again, we've been working on this all semester, so we should not expect, we should not, we should be confident that we're on the right track here in terms of our creation of a fairly lengthy but fairly robust research project. So my next tasks, the tasks for the next live stream, are going to be my qualitative results. So I'll just outline this very briefly. We've got that. We've got study. I might change that just because having looked back at the model, I picked West Virginia because I knew that Joe Manchin was saying some stuff, and some other West Virginians. Jim Justice was saying a lot of stuff at this time about. Or in this case, right, West Virginia starts to fall in line with the model a little bit. Maybe I'll keep West Virginia just for that, because that's kind of a really high leverage case then, because it goes from up here to down here as their governor starts to make a lot of statements and cues the public, whereas California goes the other direction. So that might be a good one. So we'll do the case study of West Virginia, and I'll do the case study of California. Now, of course, I know that many of you who have been thinking about your own cases are thinking these are not similar systems, right? In fact, these might be considered to be least similar system design case studies, where West Virginia has very little in common with California in terms of political culture, as well as in terms of actual like economy and sort of everything, right? And so this is kind of, I think, a nice contrast that you can do. The other type of case study comparison you might consider would be like a most similar system design, where you say, like, for example, let's look at a state with a Republican governor and that's been fairly low in this, and a state with a Democratic governor that's been fairly high, but they're really close to each other geographically. They have a lot in common, right? My thought here would be to look at let's see, let's see here. We have some states that are pretty comparable. I mean, it's hard, right? Because these states are quite, there's some real differences here in state culture that tend to correlate strongly with this stuff. But for example, Kentucky is way up here. They've got pretty high interest in medical stuff. Maybe Nebraska is a good choice here. And then down here we've got some states. Let's see, where are some states? Like plain states, right? Honestly, Pennsylvania and Maryland you could do maybe. I don't know, you'd have to look into this pattern. Kansas and Nebraska maybe, right? These two are pretty far away from each other on this variable here, and yet they're quite similar in some of the other features of their sort of case setup, right? Iowa's interesting. Iowa's surprisingly low. I'm not sure why that is necessarily. Iowa compared to Wisconsin or some of these other states, Michigan, that are sort of in the neighborhood. Minnesota and Iowa maybe would be an interesting one to look at, because where's Minnesota? I'm sure Minnesota's pretty high. Maybe not. They're not as high as I thought. Anyway, we can stare at these scatter plots all day. The idea here would be to choose a couple of these cases and again explain what's going on in there. That'll be the topic of my next live stream, where I really get into the qualitative results. And then finally, it'll be time to wrap this thing up, right? In a conclusion section, which contains a number of different considerations. So yeah, we'll look forward to those pieces in the next few live streams, and then I'll clean this up a little bit, and then we'll do the most important thing, which will be, I think, something that will hopefully be very pedagogical, something that will help you learn a lot about your own papers. Is I'm going to look through this thing and I'm going to tear it to shreds. Okay, this is not the best final project in the world. There's a lot of questions that I have, and if this were something that you were writing right now, I would go through and say, this really looks like you pounded this out over like a couple of hours, while live streaming on YouTube. There's a lot of sort of inconsistencies. There's a lot of problems between the fit between these different sections. Like, for example, here comes this variable on GDP per capita, and yet, right, in your bivariate results, and yet you've almost never described it in your threats to validity section. Like, where did that come from, right? There's some jagged edges here that we're going to need to smooth out. So again, this is not over once you get to the end of the paper. This isn't the kind of thing where we get to the bottom and we say, look, we wrote it, it's perfect, ship it away, right? We want to go back over this with a fine-tooth comb and make sure that from start to finish, right, from the very first sentence of the introduction all the way to the conclusions, that everything flows really neatly, that there are no surprises, that the audience is being sort of guided through this magical wonderland of your research with no curveballs, no weird subverted expectations, right? We want to be able to anticipate all of the moves that you're making from top to bottom. So I hope you enjoyed this. Hope this was helpful to you as you continue to write your own papers. And look forward to next time wrapping up this section and describing those qualitative results. Should be fun to see what I find when I look into some of the primary and secondary source documentation on these two very different states. So long.